Welcome to The Explainer. We're jumping right into one of the most critical phases of any AI project, breaking it all down so you can really understand how it works.
All right, so we're talking about phase 4 of the CPMAI methodology. This is model development. Seriously, think of it as the workshop. This is where all that effort you put into data prep starts to pay off, and the real AI engineering actually begins.
So you've done the hard work. Your business goals are clear, you get the data, you've cleaned it, you've prepped it, it's perfect. But now you're facing the big question. How do you take all that raw material and actually build an intelligent, working model that solves your problem?
The very first decision you have to make in this phase is a huge one. You have to select your modeling technique. And let me tell you, this is way more than just picking an algorithm. It's like an architect choosing the blueprint for a skyscraper. It sets the foundation for everything else that's about to happen.
And you've got a lot of tools in the toolkit here. You could go the traditional route, with supervised or unsupervised algorithms. You could use ensemble methods to combine different models. Heck, you could even use AutoML to speed the whole thing up. But where things get really exciting, and what we're going to focus on, are the cutting-edge options, using those massive, powerful, pre-trained and generative models.
Yeah, so for this explainer, we're going to really zero in on how generative AI fits into a structured process like CPMAI. Because it's not just about making cool chatbot demos, right? This is about how you can systematically harness these incredible tools to get real, tangible business results.
First up, let's talk about fine-tuning. Look, building a giant AI model from scratch can take millions of dollars and forever to train. So instead, you can take a powerful, pre-built foundation model and just customize it. It's kind of like teaching a world-class expert a new, very specific skill using your own company's data.
And the way you do this is through something called transfer learning. It's just so efficient. First, you pick a solid pre-trained model. Then, you get your own, much smaller dataset ready. You retrain just a tiny part of that big model on your data, and then you test it. You're basically transferring all the knowledge from that giant model and applying it directly to your specific problem. It's a game changer.
Now, let's get into what is probably one of the most important skills in AI today, prompt engineering. This is literally the art and science of how you talk to an AI. It's all about crafting your instructions, your prompts, to be so clear and so precise that the model gives you exactly what you want every single time. Just look at this example. This is not a fuzzy request like, hey, summarize this. No, this is a specific command with clear constraints. It has to be one sentence. It needs to pull out the sentiment, and it has to identify the product. A well-designed prompt like this one gives the model structure, and that structure is what leads to consistent, reliable, and actually useful results.
Now this is fascinating because it shows you that this isn't just guesswork, this is disciplined engineering. You can literally see the evolution here. Version 1, a zero-shot prompt, gives the AI no examples, and the results are kind of shaky. Then, version 1.1 uses a few-shot technique, giving it a few examples, and the accuracy gets better, but the output's a little long. Finally, version 2.0 uses a chain-of-thought prompt, which helps the model reason through the problem. And boom! High accuracy, concise output. You're documenting every step, tracking what works, and proving your approach.
But what happens when one prompt just isn't enough to solve a complex problem? Well, that's where API chaining comes in. This is so cool. You can build these incredible workflows where the output of one AI model automatically becomes the input for the next one. Or you can connect the AI to other tools, other databases. It's like building a cognitive assembly line for really complex tasks.
Okay, so whether you're fine-tuning a model or engineering the perfect prompt, there is an absolutely critical step you have to take before you do anything else. You have to design a fair test. You need a way to accurately measure how well your model is actually performing.
And the standard way to do this is to split your data into 3 buckets. About 70% of it is your training data. That's what the model learns from. Another 15% is your validation data. You use this to tweak and tune the model's settings. And that last 15%, that's the test set. You lock it away in a vault and don't touch it until the very end. It's the final exam for your model on data it's never, ever seen before.
So, we've picked our technique, we've designed our test. Now it's time to hit the assembly line. This is where we actually build and refine the model, and it's really a 2-part process that works together.
It's so important to get the difference here. Model training is pretty straightforward. You feed the model your training data so it can learn all the patterns. But hyperparameter optimization is different. That's where you're tuning the settings of the model itself, things like how fast it learns. The goal is to find the absolute best configuration to maximize performance. So you're not just training the student, you're figuring out the best way for that student to learn.
After all that back and forth, all the training, all the tuning, all the optimizing, the main engineering work of Phase 4 is finally done. You have successfully built a model.
But hold on, it's not ready for prime time just yet. The final output of this whole phase is what we call a candidate model. Think of it like your star job applicant. It looks fantastic, it aced all the interviews in the workshop, but it still has to pass one final super rigorous test before it actually gets the job.
And this really sets up the next big challenge perfectly, because a model can have amazing technical scores, but still completely fail to deliver any real business value. So how do you prove that your candidate model actually works in the real world and meets the success criteria you set up way back in Phase 1? Well, that's the ultimate test, and that's exactly what we'll dig into in Phase 5. We'll break it all down in our next explainer.